This is Unit 0, Worksheet 5, problem number 6. A spring jumper is compressed on a tabletop. It pops into the air and then returns to the ground. In order to have an isolated system, I'm going to make sure that I include the spring. I need to include the earth since it's moving up and down. I'm probably going to include the ground, which is really the earth. That would be fine if you left that out there. And I'm going to include the surrounding air. Ooh, I hope this fits. Surrounding air. Sorry, I had to shorten that a little bit. Okay. As far as things that change and what accounts we're going to talk about, if you look at the picture, big thing is, oh, I'm sorry, before we move on, I'm getting ahead of myself. Let's call the ZRL this position here at the ground. That's as low as the spring gets. As far as what changes, if you take a look at the difference between A and B, it's the shape of the spring, which tells us that there will be elastic energy changing in the system. These little arrows here and the dots tell me that the speed is not constant throughout this time period. So the speed is changing, which tells us that we're going to have to think about changes in the kinetic energy account. If you look at the spring, pops up in the air and comes back down. So we have to think about how that height is changing, which tells us we have to think about energy stored in the gravitational energy account. And then the last thing is the thing hits the ground. And when it does that, there's some sound that you can hear, and also that force makes the spring and the ground and the air around it get hotter. So we're going to have a temperature change, which tells us that we have to think about the thermal energy account. All right, a couple things I want to look at here, thinking about heights. If you look at this, at A, we're going to say, hey, we're at the ZRL. At B, we've sprung up, and you can see we're just a tiny bit up in the air. That little space there is kind of intentional, whereas at F, we're back on the ground. All right. So what I'm going to do is I'm going to include the fact that at B, you're a little bit higher than you were at A. All right, just so people aren't confused as to what's going on there. Okay, so at A, let's think about our accounts. So we have elastic energy, we have kinetic energy, we have gravitational energy, and we have thermal energy. Okay, I hope you guys can read all that. Okay, elastic, kinetic, gravitational, and thermal. And then we're going to do it again. Wish there was a redo button. That would be awesome. Do it again. Oh, I missed. Okay. So I got my bar graphs all set up. And now I'm going to think about my energy accounts. At A, the spring is squished, so we know we have to have elastic energy in the system. If we think about kinetic energy, there is no kinetic energy stored in the system there because the object is standing still. We don't have to worry about gravitational energy there because the object's at the ZRL, and our ZRL for thermal energy is always the temperature of the system at the start, because again in this class it just happens to be that our systems get hotter as time goes on, not colder. That will change as you get more advanced in your studies, by the way. All right, so here we go. If these three accounts have to be 0, that means all the energy in our system is stored in the elastic energy account. So I'm going to go ahead and just pop 6 blocks worth of elastic energy into my system. Then you'll see at B, the spring has sprung. So the spring has returned to its original shape, which tells us there is no elastic energy. Okay? There is no elastic energy anymore stored in our system. And so what I've got is a little bit of gravitational energy because now we're just a little bit higher, and a whole bunch of kinetic energy. Okay, so if you look, we've got 6 blocks at A, we've got 6 blocks at B. 1, 2, 5, 6, 1, 2, 5, 6. Yes. At C, we've scooched up a little bit higher yet. Let's go. I think we can go, oops, wrong place. We've gone a little bit higher, so our gravitational energy storage will be larger. And then it's a little bit slower. You can see that the size of the arrow has changed, right? So a little bit slower, which means there's less kinetic energy. And again, if we've got 6 blocks at A, 6 blocks at B, we have 6 blocks at C. So now we've got 6, 3, and 3. Hey, if you made this 2 and 4, would it be okay? Sure it would. If you made it 1 and 5, would it be okay? Yeah, sure it would, right? So there's multiple answers you could put here as long as gravitational energy is increasing, kinetic energy is decreasing, and the total number of blocks is equal to 6. At D, though, there's really one right answer. Hopefully you're thinking along with me. At D, the spring is in its original shape. The spring is not moving. The spring is as high as it's going to be. So what we've got here is that all the energy in the system is stored in that gravitational energy account. Okay, so you can see that what's happened is here we've traded elastic energy at the beginning for gravitational energy at the end, or in other words, we squish a spring and we turn that squish into the height of the spring at D. I guess turn into is not really the right word, is it? At E, we're moving down, so there must be kinetic energy stored in the system, and we're lower than we were at D, but higher than we are at F, so there has to be some gravitational energy stored in the system. We're also lower than we were at C, right? Can you see that? So we have to have less gravitational energy than we have at C, so I'm going to go ahead and just call that 2. If you need to, you can use fractions of blocks, by the way, right? So if you kind of painted yourself into a corner with the number of blocks you had at B, you can kind of use half blocks to kind of wedge things in there the way to make them fit. And if I've got 6 blocks at A, B, C, and D, I have to have 6 blocks at 6 blocks at E. So that means I must have 4 blocks of kinetic energy. Okay. Hey, what you can see there is at C, I'm moving slower than I am at E, right? C is slower than E. I suppose I should erase these lines that I drew in here. Okay. Now, we've got at F. At F, the spring is in its original shape. It's standing still. It's at the ZRL. That means all of these energy storage accounts are equal to 0. There's no energy stored in those accounts. So where is the energy? That's right. All of that energy is stored in the fact that the system is now hotter than it used to be. So we've got 6 blocks of thermal energy. And that's number 6.